What's up, everyone? So I am back with a follow-up video to a series of repair videos I did on a power supply for a Beckman Coulter Optima XE-90 Ultracentrifuge. And so this power supply provides 24 volts to the input-output board, which it has a more official name. Forget what it's called off the top of my head, and then the motherboard, and also 60 volts to the thermoelectric module, or the TEM. And so I think I did this. Well, this supply initially got tripped up with this fault. I believe it was in November of last year. Okay, and so I did a series of videos on it. It ended up being, well, let me kind of go over how this supply, the topology of this supply. Okay, so this is the main board for the supply. This is where the input voltage is filtered. The PFC is on here, and so this supply is providing 400 volts DC, and then you've got these DC-DC converter modules. All right, so they take that 400 volts, they step it down to, one of them is 24 volts. I think it provides up to 8 amps. And then you've got two other modules that provide the 60 volts, and they are in parallel. So they, by themselves, they provide up to 4 amps. In parallel, they provide a total of 8 amps. Okay, now on this supply, the fault initially was, so this is one of the 60 volt DC-DC converter modules. These are the two primary switching MOSFETs. So first time this thing faulted, both of these I found shorted. Okay, and then on the 24 volt module, which I believe is this guy right here, you see, yeah, it is this guy. There were some SMD components that literally just fell right off of it. And they were actually one of them was a TL431, which is a reference, basically it's involved in the feedback circuitry of the switch mode power supply. Completely just had fallen off the board. They were missing. I don't know where they went. I didn't see them, but they were definitely gone. So I replaced those, replaced the MOSFETs, put the whole thing back together. Wasn't a straight repair. As you can see, there were 3 videos in that series that I did before it got up and running, but basically that was the gist of it. Worked fine for, let's see, a little over 6 months, and now the end user was running it, heard a loud pop, the whole thing screen went blank. And same thing, the MOSFETs for one of the 60 volt modules, the same exact one, which is this one right here, were shorted. And of course this internal fuse down there, that little green guy, was blown to bits. Alright, so I replaced those MOSFETs, replaced the fuse, put it all back together, got it into the unit. There is a service code for these centrifuges that you can put in, so you have a little bit more access to monitor some of the voltages on the unit, perform calibration. So I was monitoring the voltages and the current on the TEM, and it got up to about a little over 50 volts, a little over 7 amps, and then heard the fuse blow again. And of course it was those MOSFETs that blew again. And also there was I just had this thing powered on, so I need to discharge the caps, but on the underside of this, there is a MOSFET driver IC for the PFC that had also got damaged as well, because when I replaced the MOSFETs, powered it back on, the PFC wasn't working. I was only getting 160 volts, and there was a short from gate to source on the large PFC MOSFETs. And so I replaced that gate driver IC and now we're back up to 400 volts. One thing I did want to point out is, take a look. I'm not sure if this will come up nicely on camera, but take a look at these two 60 volt DC-DC modules. Look at the one on the left, and then look at this one. Now, it's not really coming up all that well on camera, but you can see on the sides of this transformer, look at the dark color. Look at how nice and blue this one is. So that started making me think there must be some internal well, I shouldn't say must, because I'm not 100% sure, but it almost looks like there could be some internal degradation on this transformer. And once you get up to a high enough current, either a short within a winding or a short across primary and secondary, some current leakage, that could be causing these MOSFETs to short. So I removed both of these transformers. I did a high pot test using my high pot tester. So it was a little bit inconclusive. That doesn't really necessarily rule out a short within a winding, which is, you need to do a different test for that. I would like to give that a try, but I've already put them back into the board. Obviously, you have to remove the transformers from the circuit to do this test. But what I did do is I swapped the transformers. All right, so this module here is the one that would initially have the blown switching MOSFETs, and that's the new ones there. You can see this one still has the originals. I'm not a big fan of the way that these have been designed to dissipate heat. So they have these little rubber coverings that go over them, and then let me see if I can find, yeah, see. And then you've got this little crossbar that goes on this side of them, and then a screw that holds them close to the casing. Not a very effective mode of heat dissipation. So if these things are getting too hot, that's obviously going to lower the amount of current they can handle. So I'm going to put this thing back together. We're going to put it back in the centrifuge, see how it does, and then I'll follow up with you guys to see what the outcome is. Alright, so we've got the modules connected. I've got my meter. This one, I believe is hooked up to the 24 volt module. This one is hooked up to one of the 60 volt modules. So let's power this thing on and see what happens. Alright, well, that's good. So we know that one of these is working. Alright, and so this is the other module. And so you can see that both of these two are the 60 volt 4 amp modules, and they're usually connected in parallel. So you get your 8 amps. I'm going to finish assembling this guy, pop it back in the centrifuge, turn on the TEM, and see how it does. Alright, so we're back in the electronics lab. I did put this guy back in the centrifuge, and it did blow another fuse. It took a little bit longer for it to blow, and it also wasn't as catastrophic. So for example, the fuse didn't just explode like the other ones have. This is the one that blew, but all the same, it blew. And it blew those two MOSFETs, and also it didn't follow the discolored transformer. But what I'd like to do is conduct an experiment with a load test on each of these. And I think I've done this before. These modules have an output logic connector, and this is it right there, the numbering or for each of the pins on the connector. This number 3 that says V_prog, that is the remote adjustment. So that is how this supply is able to, or that the main board on the centrifuge is able to adjust the supply up to 60 volts depending on what it needs. So what I've done is I've hooked a positive lead to that pin number 3, and that's it right there. It's connected to my power supply, and then of course we have the black lead connected to ground, which is just one pin on that transformer. And I found that by adjusting it up to 6 volts, that gets 60 volts on the output. And so that's what I'd like to conduct this test at. With the single module, we should be able to get 4 amps. Alright, and so this is the module that, although it has the quote-unquote bad, we'll just call it the discolored transformer, should be able to get 4 amps. I still need to replace the MOSFETs on the one that the shorted ones, so we'll do that. But we'll try it on here and see how it performs. So we've got meter on the output to just check the voltage. Now, because I adjusted that voltage adjust pot, that blue pot there, trim pot, I think it usually sits at 34 volts for some reason, and I brought it down to like 31, so I'm not going to go all the way to 60. I'm going to, usually on the centrifuge, for example, it gets up to about like 53, 54 volts, so we'll leave it there. But we should still be able to get 4 amps out of this thing. So we're close to. So I'm going to power it on, and we will give this a try. So let's turn on the isolation transformer. And that's interesting. It's already at 15 volts. I don't know why that is. Okay, so now it's back to normal. So let's turn this guy on, and I'm gonna keep my camera on the meter and alright, I'm gonna leave it there. We're at 6 volts. Alright. And so now let's turn on the electronic load. We'll start at 1 amp. And see what happens. All right. Okay, can do 2. I have to put my safety glasses on. Okay, it's doing 3. It's doing 3.5, 3.6. Alright, so it's at 3.9 amps, so it's able to handle that. This one module is able to do that. Alright, let's turn the load off. And yeah, I'm going to get that other module repaired, and we're going to repeat this test, the other 60 volt module, and see how it does. Alright, so we got that other module in that keeps blowing MOSFETs. Replace the MOSFETs. Again, we're starting at 10.3 volts, which is normal. Let's turn on the DC supply so we can get it up to roughly 60 volts. Whoa! Holy crap. Whoa. What is going on there? It did not like that. Whoa. What the hell was that about? I don't know if you can pick that up, the direction. It's definitely coming from that large inductor L13. Wow, I can't believe this, but there was a little, I don't know if it was a solder bridge or what, but these were initially, I just measured them initially. We're testing short, gate to drain. And yeah, there was a piece of material, but I removed it. It's no longer testing short. I think that was what the problem was. So I'm gonna clean this up a little bit better. There's still some flux residue around there, and on the top as well. And then we'll try this again. All right. So if we haven't found the problem, this thing is gonna start buzzing away once I turn it on. So let's give it a try. Yep, that was it. Alright, so we got the voltage adjust connected. I'm going to power this thing on, and again, we should see it go back down to 10 volts on startup. Yep, alright. Let's power on the DC supply. Okay, it's not making any crazy sounds. Alright, we'll leave it right about there. Okay. So now let's conduct the load test, and we'll bring this back down to 1 amp. Turn the load on. Okay, and then we'll just do the same thing. See what happens. Alright, it's doing 2 amps. It's doing 3. I think from here we can just okay. We're at 4 amps. Oh, whoa, look at that. We're smoking. Yep. They're smoking. Wow. Oh, shit. Yep. Yep. Ooh, that was loud. Well, guys, I think I might have found the culprit. It's this SOT23 MOSFET, N-channel MOSFET. I just mounted it on this board to make it easier to probe. Which, by the way, I also used this for SMD components to put on the curve tracer. I originally got this for a microcontroller to do some, either flash it or test it, but it's really neat for using as a test fixture, especially for like SOD 1, 2, 3 diodes, but it works for SOT23 too if you position the component correctly. And then each of these pads connects to an easy pin on the other side where you can connect your these long test leads. So it works great for that kind of stuff. But anyway, yeah, so these MOSFETs are N-channel. I think it's a 2N 7002. Mid voltage. I forget what voltage they are, like 30 volts or so. But let me see, what am I doing here? Yeah, so they are, hold on. Yeah, so they are located right here. Okay, so there's one for each MOSFET. And I don't know if it's a gate MOSFET or what. Let me see. Connects to this pin here. Yeah, which is the gate. So it's some sort of signal MOSFET, I guess. I'm not sure. But both of them were short. Alright, and it's a little bit difficult to test these in circuit because you've got these 10 ohm resistors nearby and these Scotch key diodes. So, you know, it's really difficult. They would, if they were normal, they would test short in circuit, which is why I completely missed them. And I probably should have looked at them sooner before going, you know, other routes. But the transformer, man, with it being so discolored, really threw me off. And especially because it only seemed like it would fail at high current. So, you know, that got me thinking, well, maybe you get the current high enough, it will, you know, you'll get that current leakage causing the short. But I might be speaking too soon, so now that I've got the replacements in, I am going to, I still got it. I also, by the way, checked all these little diodes, these 500 milliwatt, there's some 15 volt Zener diodes and some 1N4148 signal diodes. I checked all of those with the curve tracer and all of them look great, so I don't think those will be a problem. But this is the board actually that that's been the problem, so let's put this on the electronic load and see how it performs with the new MOSFETs in. Okay, so we got everything hooked up. I'm gonna power on the isolation transformer. Alright, we've got our 10 volts, 10.3 volts there. Let's turn on the remote voltage adjustment. Now we're up to 54. Okay, moment of truth. So we'll know pretty soon if this works because they'll start smoking pretty quickly. So I'm going to turn it on, the electronic load on at 3 volts, at 3 amps, I'm sorry. And start bringing it up. Yeah, I'm seeing smoke. Yep, it's still smoking. Unfortunate. So, wow. Wow, so that does not appear to be the culprit. And those MOSFETs shorting just could have been a secondary fault from the originals blowing. But obviously there's still something else at play here. Alright, y'all, so after, you know, looking at those MOSFETs and replacing them and that not resolving the issue, you know, I decided to look at the 2845 PWM, the current mode PWM. Okay, so that is what's controlling the switching of the high power MOSFETs. That SOT MOSFET is in that signal chain to the gate of the high voltage switching MOSFETs, or high power switching MOSFETs. Okay, so I wanted to look at the PWM and see what's going on there. So right now, I've already looked at the one that has a problem, and right now we're looking at the 24 volt module. So we're going to probe pin 4 of this PWM, which is the oscillator. And the frequency is switching on and off, but it's roughly 220 see if we can trigger on that a little better. Yeah, so we're looking at roughly 220 kilohertz is the frequency. On the module that's giving us issues, I measured it at 2 megahertz. So something that's definitely not what it should be. Even regardless, even though the modules are different, I don't even think that the 2845 is capable of that type of switching frequency. So something is either wrong with that module, or the capacitor, resistor, that circuit that selects that switching frequency is something's wrong there. Wow, so this might be hard to see, but I was I was about to remove this PWM, and or even this capacitor, which is part of the oscillator circuit, and I noticed something a bit strange. It almost looked like the portion where at the end that actually gets soldered to the pad had separated from the actual capacitor. It looked like that, and then sure enough, once I started desoldering it, it just came right apart. And I know it's probably difficult to see. Yeah, you can see it right there. That's the end of it. Yup. So that's a problem, and that could be messing with our results. So I'm not sure what value this thing has. There's no way to check it now, but I'm going to remove one from the working board and see if we can measure it. I have plenty of these ceramic SMD caps on hand, so should have a replacement value, but crazy. Hopefully that's the culprit. Okay, so I put in that replacement cap. It measured to be about a 220 picofarad capacitor. Did have that in stock, and check that out. So I just paused the screen just to make it easier, but look at that, the frequency right there using the cursor, 277 kilohertz. Okay, so I think this is close to what we want to see, and this might be the culprit. So I think I've said that before, but we'll see. We'll see if this thing starts smoking. All right, so now we are monitoring the load. I actually just bought these nice little test lead clamps. So just clamping right on the PWM. We're gonna turn on the remote adjust. So we are now at 54 volts, and let's turn on the load. Okay. Okay, so that looks a lot better than how it was looking before. And I know I didn't show you guys this, but it just looks a lot cleaner. It looks comparable to the 24 volt module. But let's go up a little higher. So now we're at 2 amps. And I think I'm starting to see smoke. Can't really tell. Maybe not. Maybe we should go a little higher. It's still not smoking. Let's go up to 3. Because I'm just worried about blowing another fuse. Because then when the fuse blows, it sometimes blows the PFC circuitry, and I just really don't feel like going through all that. So that's why I'm really trying to keep a close eye on the smoke. Usually that's the telltale sign. I think we might have fixed it. It's still not smoking. Wow. But you can feel the heat coming off it. I mean, again, this thing gets really, really hot. I'm going to stop it because it definitely would have started smoking by now. And these components have been under a lot of stress. I want to replace these MOSFETs. I might even replace the PWM because, you know, I don't know if it was supposed to be putting out that high of a frequency due to that bad capacitor. But let's turn the load off. I think we fixed it. So I think this is what I'm speculating. I think due to that, this thing gets so hot. I mean, again, the components have literally fallen off of the 24 volt module the first time this thing failed. I just don't think they've got the heat. There's either two things going on. The manufacturer of the centrifuge should have picked a higher rated supply, because the TEM gets up to close to 8 amps. This module is only putting out a max of 8 amps in parallel, the two of them. And so they should have went with a bigger power supply that could handle more current. But, you know, that, and also maybe the manufacturer of the supply could have done a better job with dissipating heat. I mean, because components should not be falling off the board. I mean, that actually happened on the 24 volt module, which isn't, I mean, I'm not 100% sure what, I can check the monitoring system again on the centrifuge, but that one doesn't get nearly as high as far as the power output. So, and that is the one that literally SMD components had fallen off the board. So I think it's a combination of two things. Poor heat dissipation on the supply end, and then the manufacturer of the centrifuge not picking a suitable supply. But yeah, I think we got it. So I got a lot to do as far as I've switched components around from board to board, and I got a lot to do before I can put this thing back together and test it again. But I think we found the culprit, which is awesome. Alright, so I got the replacement diode in, the Zener diode, that 15 volt Zener, and all the modules have been reassembled. The outer casing that also acts as a heatsink has been reinstalled on each of them, and they are good to go. So I figured what would be fun to do is do a final load test on each of them, and also monitor the PWM, the output of it as the load changes. I thought that would be pretty neat, and so that's what you're gonna got the camera focused on. Not only you got the electronic load, and then the scope as well. So I'm gonna power this guy on, and hopefully everything works as planned. We're starting with the load that had the initial fault. Okay, so I'm gonna turn on the voltage adjust supply. Alright, so we're up to 54 volts, and we're going to take a look at the oscillator pin 4 on the PWM. Okay. Ooh. It's at 280 kilohertz. This is the output. Oops. Okay, so I think what we can do is bring this up to 1 amp and see how the output changes. Yeah, so look at that. Cool. Alright, and then let's keep increasing the load. Alright, we'll go up to 3. Okay, let's do 3.5. So far so good, and that's just the electronic loads fan turning on. And we're at 4 amps, and nothing is smoking. Alright, but it looks like the PWM is switching properly, even at the max load. So, I'm not quite sure what else could be going on here if it wasn't that capacitor. But let's take a look at the other ones, see if there's any differences. We'll start with the other 60-volt module. Alright, so this is the other 60-volt module that we're going to do next. Switching frequency does appear to be a little different, a little lower at 260. So that's interesting. Might be worth replacing that PWM. I don't know though, because everything else should be the same. I don't know if that cap being like that put more stress on it, but yeah, the switching frequency is a little lower as well. So we're at, I think the one we tested first was at roughly 150 kilohertz. This one is at 130, 135. Okay. $25. All right. So it looks like we're looking good here. Alright, so this is the final test I'm going to do. This is the 24-volt module. So let's power it on. And we're looking at roughly 230. Alright. So we're looking at 120 kilohertz. Alright. Let's turn the load off. We'll shut this guy down. I do want to check the first one that had the fault one more time. Alright, so back to the original module. And yeah, it's 150 kilohertz roughly. Yeah. Other than the frequency, I'm not seeing a difference. Everything looks steady, so I think we're good to go. I'm going to reassemble this thing. Done with testing, pop it in the centrifuge, and we'll see how it performs. This is definitely the longest the unit has ran since the power supply has had that initial fault. So normally it would blow right away. I am concerned about how long it's taken for it to reach the set temp. I forget how long that would normally take from being at ambient. Well, it took a while, but it did get down to 4C, and I'll have to speak with the end users because I'm not sure how long it normally takes to get to 4C, but what I'm going to do now is I'm going to run their normal program run. What they would normally run this at, they always run it at the same settings, 29,000 RPM for about an hour and a half at 4 degrees C. I'm going to run that. I have a good, I'm feeling positive. I think it's going to do fine. and then that'll be the final test, and we'll wrap up. Alright, well, that is a wrap on this one, at least for now. Sorry, it's really loud in here. You've got the centrifuge going. We've got these ultra-centrifuges, ultra low temperature freezers going. So it's loud, but yeah. So it finished the hour-and-a-half run. It's reached the set temperature of 4 degrees Celsius. So that's really all that I can ask for at this point. You know, just some closing thoughts. You know, I'm a little bit, well, disappointed, definitely, with this power supply. I mean, it's barely 3 years old. Well, about 3.5 years old. And it's had these 2 major failures. And while they do seem related, because they are the same 2 MOSFETs that are blowing this internal fuse, the failure modes or primary cause was different. In this case, it was the it seemed to be, in this case, the capacitor that sets the oscillator for that UC2845. I might be saying that wrong, but that current mode PWM. It looked like it was that frequency, that oscillator frequency, was way above what it should be, and it was basically driving those MOSFETs to failure. That's what it seemed like what was going on here. That is not what happened the first time this thing failed. Different, you know, you had those SMD components fall off the 24 volt module. So, I mean, clearly this power supply has a problem with heat. It's not dissipating that heat effectively. Everything is getting way too hot, and it's stressing out the components, the internal components. That's really the only way I see that ceramic cap failing in the way that it did. I mean, it literally fractured right at the point where it connects to the pad. So that really seems only possible via thermal stress. But maybe you guys in the comments, you guys might have some additional thoughts. I have reached out to the manufacturer, and I should have reached out to them when this happened initially, and I didn't. I got busy with other things. But this time I did make sure to reach out to them, let them know about the first failure and then the second failure. I'm curious if they have reported these failing prematurely. I mean, to me, this is definitely a premature failure. I mean, 3 years. It's very suspicious that the warranty given by the manufacturer of the supply, which isn't Beckman, it's Hugio Magnetics, they give that supply a warranty of 3 years, and it literally failed right after that warranty. But power supplies like this, they shouldn't be failing within 3 years. So, you know, as I was saying, I reached out to Beckman today, so I'm not sure when they'll get back to me. Curious what the cost of a new one is, and if they're still using this same manufacturer for their switch mode power supplies in these. But that's all that I've got, really. You know, if you guys have any feedback, please, as always, leave them in the comments. And hope you guys found this interesting. And I'll catch you at the next repair. All right.